Okay, well, here we go. We're going to be learning about percent composition today. All right, so first of all, percent composition is meant as percent by mass of each element in a compound. In other words, let's say you have the compound carbon monoxide. Well, what percentage of carbon monoxide is carbon and what percentage of carbon monoxide is oxygen? Again, percent by mass. All right, so there's a formula you need to know, and this formula is the mass of the element divided by the mass of the compound times 100 gives you percent by mass. And of course, if you were to add up all the percentages of the different elements in a compound, they should add up to 100. All right, so let's learn. How do we find the percent composition if we are given the chemical formula of a compound? So we're going to start by looking at finding the percent composition of water, H2O. All right, well, we're going to start with the assumption that we have 1 mole of compound. I have nothing to write down about that, but we are assuming 1 mole of compound, and that's going to help us. All right. The second thing we need to do is calculate the molar mass of that compound. So I've done that here. I've got 2 hydrogens times the molar mass of 1.01 grams per mole gives me 2.02. For oxygen, I've got one of them at 16 grams per mole, so 1 times 16 is 16. Add these up together, and I get a molar mass of 18.02 grams per mole. All right, so now that I've got the molar mass of my compound, I can determine from the chemical formula how many moles of each element are present in my 1 mole sample. All right, so looking at the formula H2O, 1 mole of H2O contains 2 moles of H. We know that because of our subscript. 1 mole of H2O contains 1 mole of oxygen, and we know that from our invisible 1 subscript there. So we have 2 moles of hydrogen and 1 mole of oxygen in 1 mole of water. Okay, moving forward. All right, the next thing I need to do is determine the masses of each element in the compound. So let's do that. All right, if the molar mass of hydrogen is 1.01 grams per mole, and I'm talking about H by itself, not molecular hydrogen, but hydrogen as we would find it in water. Okay, 2 moles of hydrogen times its molar mass, 1.01 grams per mole, okay, is going to give us 2.02 grams of hydrogen in 1 mole of water. All right, with a molar mass of 16 grams per mole of oxygen, 1 mole of oxygen times the molar mass of 16 grams per mole gives us 16 grams of oxygen. So 16 grams of oxygen in 1 mole of water. All right, the next thing we want to do is divide the mass of each element in the compound by the molar mass of the whole compound, right? Remember that the molar mass is the mass of 1 mole, and we are assuming 1 mole of our compound. All right, so for hydrogen, we had 2.02 grams of hydrogen. And we're going to divide that by 1 mole of water. Remember, we calculated the molar mass at 18.02 grams per mole. Therefore, 1 mole has a mass of 18.02 grams. Okay, so do the division. 2.02 divided by 18.02 times 100 gives us 11.2% hydrogen. So the mass of water is 11.2% hydrogen. Now, let's take a look at oxygen. Okay, 1 mole of oxygen divided by 1 mole of water times 100 gives us 88.80%. Now you may be wondering why these don't have the same sig figs, and that comes from here, right? This is what determines our sig figs. So here we have 3 sig figs. Our answer has 3 sig figs. Here we have 4 sig figs. So our answer needs to have 4 sig figs. All right. So this is our, by the way, our percent by mass formula, the one that we just wrote down. Okay. So there we go. We figured out the percent by mass of the elements in water. Now let's take a look at a little bit more complex molecule, glucose. So glucose has the formula C6H12O6. So for every 1 mole of glucose, I have 6 moles of carbon, 12 moles of hydrogen, and 6 moles of oxygen. Okay, so let's run through this with less annotation this time. The first thing I want to do here is I am calculating the molar mass of glucose. All right, I've got 6 carbons with a molar mass of 12.01 grams per mole, giving us 72.06. I've got 12 hydrogens at 1.01 gram per mole, giving us 12.12 grams per mole, and 6 oxygens at 16 grams per mole, giving us 96 grams per mole. So if I add these down, I get the molar mass of glucose is 180.18 grams per mole. All right. Now I want to find out the mass of each element in the compound. Now it turns out that I just did that. Okay, up here you'll notice this number matches this number. This one matches this one. And this one matches this one. Okay, so for 1 mole of our glucose, we've got 6 moles of carbon. Or we've got 12 moles of hydrogen, or we've got 6 moles of oxygen. And here they are itemized out. All right, so the mass of each element in the compound. All right, and then the last thing we have to do is take those masses and go ahead and calculate what the percent by mass is. So we're going to take each one of these and divide it by the whole molar mass. And that's going to give us 39.99% carbon, 6.727% hydrogen, and 53.28% oxygen. And of course, I added these up to double check. They do add up to 100%. It's not necessary to do that, but it's a good idea. Just double check. All the parts have to add up to a whole. If they don't, you've made a mistake somewhere. So that's a way to catch them. All right, stay tuned for some homework and possibly a couple of support videos on this topic. And hope to see you soon. Bye.